and let's get started. So the fundamental theorem of calculus sounds big. So let's look at the theorem first and then break it down a little bit, and then we'll put it to use. So f is continuous on a function, closed interval a to b, and cap f is any antiderivative. That just, by any antiderivative, they just mean constant is unknown, but we really don't care. And in fact, when you look at this formulation, the constant doesn't show up anywhere, and I'll explain why in just a minute. But if we take the integral from a to b of f of x dx, then the way we calculate it is we find out what f is the derivative of, so the antiderivative, cap f, and we insert b, and we get that result, and then we subtract f with an input of a, and that turns out to be, one thing we saw is that it represents the area under the curve of f above the x-axis between a and b, or the opposite of the area if it's below the x-axis. But let's take a look at this and kind of another way of looking at what they're saying here. So I'm just going to say if cap f of x plus some constant c is equal to integral of f of x dx, then the integral from a to b of fx dx is equal to f of b minus f of a. I really didn't say anything new here. I've just extended this a little bit. And notice that the constant, so this me adding the constants, just them saying is any antiderivative. And just to kind of if we plug that constant in there, and I took f of b plus the constant minus f of a plus that constant. Well, when I get rid of the brackets, this is why the constant doesn't matter. Because I'm distributing this negative to the same c that I've added over here, and it negates itself. So we just end up getting an f of b minus an f of a. Okay, so here's the big deal. And want to also introduce some notation. If I take and put this bar here, this is my lower and my upper bound. So I'm going to take f of, once I figure out what cap f is, I'm going to put it into this notation, and this is a way of shorthand for f of upper bound minus cap f of lower bound. Okay, so once we figure out what the integral of little f is, we're going to put it out here in front of this notation bar, and we'll see that put to work here in just a minute. So if let's say I had an integral of x dx, just to make life easy, I'm going to write integral of 2x dx from, say, -1 to 7. Okay, so that's 2 times the integral -1 to 7 of x dx. So that's going to be 2 times x squared over 2 running from -1 to 7. See, I've now figured out cap f because it's the integral. And then the 2 over 2 is just 1. So really this is just x squared running from -1 to 7. And now I'm just going to take 7 squared minus -1 squared to get my result. So that's 49 minus 1 equals 48. Okay. So that's our first example of that. Let's take a look at it with a different example, a couple of different examples. This one's going to get kind of lengthy, so hopefully I'll have enough room. If not, we'll see. Okay, so this is asking us to evaluate the integral from lower bound of 1 to an upper bound of 2 of 1 over x dx. Well, if we remember, the integral of 1 over x dx is equal to ln of the absolute value of x. That's in our properties. So this is going to be equal to cap f of x, which is ln of the absolute value of x, running from a lower bound of 1 to an upper bound of 2. So now I've got the notation in place. I just plug things in. ln of the absolute value of 2 minus ln absolute value of 1. Well, the absolute value of 2 is 2, so this is ln of 2 minus ln of 1. Now, ln of 1 is 0, because e to the 0 would equal 1. And ln of 2 is roughly 0.693. Okay, so there's another example. Now this one, it's really just a bunch that we have to split up and do independently. And it just takes a lot of white space. So let's get started on this one. We're going from 1 to 2 again. It's 2x plus 3e to the x. Any questions so far? Minus 4 over x dx. All right, so I'm going to put some properties together all at once here and split this out and make that 2 times integral from 1 to 2 of x dx. So that's this part. Plus 3 times integral from 1 to 2 of e to the x dx. Minus 4 is on top, so that's 4 times integral 1 to 2, 1 over x dx. Okay, so now that we see what we need to do, this is going to be, well, we just saw this, x squared over 2 times 2, so 2 times x squared over 2, running from 1 to 2, plus 3 e to the x, because the integral and the derivative of e to the x is e to the x, running from 1 to 2, minus 4, and then this becomes ln of the absolute value of x, running from 1 to 2. Okay, so this part is x squared, running from 1 to 2. I don't want to rewrite so much. Let's just cancel that out. All right, so this is going to be 2 squared minus 1 squared. plus 3e squared minus 3e to the first minus 4 ln, absolute value of 2 is 2, minus 4 ln 1. Okay, so 4 minus 1 is going to be 3. Plus 3e squared minus 3e. And since that's just 0, this will just be minus 4 ln of 2. And if we put that into the calculator, we're going to get roughly 14.24. Okay, so a little bit of white space needed for something like that. Okay, we're going to revisit substitution as a technique when we see something like this. And you have the option of, after you've created your substitution, you can actually rewrite it in terms of u, which is probably the way I prefer to do it because it's fewer steps. So we'll do it that way. And we may come back and do it the other way as well. But so anybody have a suggestion for what to use for u here? What looks like the best candidate? Oh. Anybody? Okay. Hopefully you're thinking of this portion here because it's the expression that's at the highest degree of the variable. So I'm going to go with x squared plus 10. Okay, and then maybe you're not remembering the substitution process, but we figure out something for u, and then we take differential du equals 2x dx. And then now we know that x dx, if I divide by 2 on both sides, we know that du over 2 is a substitute for x dx, which is the other part that shows up. Thus, we're going from x equal, remember these are in terms of x, so I'm going to, since x is no longer appearing in the integrand, I'm going to just not get that confused by saying x. Okay, so u is this part, so that's 1 over u, just based on what we chose to be substituting, and then x dx, we can now use du over 2. Okay, so what I want to do now is use the fact that u is equal to x squared plus 10. And we can recalculate these and make them in terms of u instead of x. So if x equals 0, u is equal to 0 squared plus 10. And if x equals my upper bound 5, then u equals 5 squared plus 10. So now I can change this x equals and just put it in native form and say, okay, we're looking for the integral from u equals 10 is the lower bound and 35 the upper bound. And I'm going to bring this 1/2 out in front of 1 over u du. Okay, so this equals 1/2 ln abs val of u running from 10 to 35. So the absolute value of 35 is 35. So we're looking at 1/2 ln of 35 minus 1/2 ln of 10. Okay, if you put those into a calculator, you're going to get roughly equals 0.626. And notice I got my answer without ever having to go back to x. Okay, if I wanted to go back to x, I would do it at this point. So alternately, we could say, let's run this 1/2 ln of the absolute value of u, which is x squared plus 10. Let's run that from 0 to 5. And then you'll notice that you'll get the identical thing that you got here, because now instead of doing it here, we're doing it here. So that would also be 1/2 ln of 35, 5 squared plus 10, minus 1/2 ln of 0 squared plus 10, absolute value. Okay, so your choice. All right, so we'll look at an application of this. If a company makes X HDTVs per month, and just a refresher here, remember that monthly marginal profit is different from monthly profit. And if monthly profit is P of X, then monthly marginal profit is P prime of X. So they know P prime of X, but they don't know P of X. So company manufactures X HDTVs per month, and P prime of X is 165 minus 0.1x, and this is just a domain. Company is currently manufacturing 1,500, so currently planning to increase production and we want to find the change in monthly profit. So we want the difference, not in monthly marginal profit, but the difference in monthly profit. So that's P of X. So if we changed from 1,500 to 1,600, what's the difference in monthly profit? So that would be P of the new monthly production. How does that change from a monthly production, the old one, 1,500? And that's equal to we're kind of thinking backwards here. And they gave us p prime of x. Okay, so since we have the actual p prime of x, we can figure out what the p of x that we need is. So that would be 165 x minus 0.1 x squared over 2 running from 1500 to 1600. Okay. Okay, notice I didn't split this out into two separate ones. I just did the integral. So this is another way to do it. We could have said equals integral 1500 to 1600, 165 minus integral 1500, 1600, 0.1x. Oop, this should be a dx here. Okay, but we would have just come up with this and had to do them separately. So as long as we keep this all together. So substituting, I'm going to have 165 times upper bound 1600 minus 0.05 1600 squared. Okay, so that takes care of that. Minus 165 times 1500 minus 0.05 1500 squared. Okay, so 136,000 minus, this turns out to be 135,000. Okay, so the monthly profit goes up okay. All right, so we're used to getting p of x and finding p prime of x. Now that we've learned the integral, they're just giving us p prime of x, and then we're utilizing p of x in our result. Okay, so in an application, look for a way to use the integral. It might not. I realize that this might not have jumped at you right away, but if you're given a p prime of x in an application and we're working with the indefinite integral, start at the very least by taking the integral, and then maybe it'll kind of come together for you what the lower and upper bound would be in the context. So, because another problem is going to be described a little bit differently, but generally you're probably going to need to use this fundamental theorem here. Okay, we've gotten through the examples I want to get through, and we've got quite a bit of time left. So if you have any questions, this would be a great time to do it. I don't have an assignment online for you, but I'll get one for you in the next 2 hours. You'll find it pop up there. And anything else? Let's see, I'm going to go ahead and stop the recording.